Hi there! We are going to talk about oblique triangles under specific situations where the law of sines can no longer be used to solve for the remaining parts or the measurements of the remaining parts. Here, we have these three different triangles, and when you're going to examine this one, these are neither AAS, ASA, or even the SSA situation. When you see these triangles, we can notice that what are given here are two sides here and an included angle. Same as true with number 2, we have two sides and an included angle. If we are going to examine closely number 3, we could also observe that this angle here represents a vertex where its opposite side is a side measurement y. But the given are z and x, that would automatically mean that this angle here is also an included angle of side z and x. In these specific situations, we can no longer use the law of sines since the law of sines allows us to make use of the ratio and proportion of pairing the given angle to its opposite side. And if one ratio is given, let's say one angle is given with a measurement and the value of its opposite side is also given with a measurement, we can solve for the rest. However, for number 1, the given angle is angle C, but the measurement of its opposite side, AB, could also be represented by small letter c, is not given. The other side given here, we have CB, which measures 2, and CA or AC, which measures 5, doesn't have its pair, which is an interior angle measurement. Hence, again, we can no longer use here the law of sines. So for specific situations under SAS, we are going to use another set of formula under the law of cosines. So in this case, instead of trigonometric ratio sine, we are going to have a formula using a trigonometric ratio which is in cosine form. The law of cosines tells us that the square of one side is equal to the sum of the squares of the other sides less twice the product of the given sides and the cosine of the included angle. This formula might be too long. I could also show you a derivation for this if you would like to. This formula is actually what we need to use to solve for the remaining parts of this oblique triangle. We cannot use the easier law of sines because of the situation, and hence we are going to deal with this. Now, this formula might also be changed depending on the type of side unknown or given. Let's say if the side unknown is b, so the formula could be changed as b squared. So you have a squared plus c squared minus twice the product of the known. So we can no longer use b. So you have 2ac times cosine. And instead of the include angle c, that would be include angle b. And the pattern will go like this. The unknown side here is the include angle here. So unknown side b include angle b as well here. And lastly, you could also change it in this manner. If it's a squared, then you could have b squared plus c squared minus 2bc. And now the include angle is angle A. I'm showing you these three forms so that you would understand that the situation or the formula will depend on what situation the oblique triangle will fall in. And as a matter of fact, it's not always C, A, and B because in item number 2 and number 3, we have been using different vertices and hence the side measurements will also have different variables aside from A, B, and C. What you just need to remember is this: the unknown side measurement The square of it is equal to the sum of the square of the known side measurements less twice the product of the product of the two known side measurements times cosine of the included angle, which is again directly opposite of the known. We are going to use this in this formula to solve for the value of C here and probably for the rest. Once we could solve side C measurement here, we could also journey with different options, but let's have it later. Let's talk about side C first, since this is the side which is directly opposite the included angle. So we are going to use this formula here. That would mean C squared is equal to that. But since we're looking for just C, not C squared, we can take the root of both sides, and hence C is computed as now as the square root of a squared b squared plus b squared minus 2ab times a cosine c. So a is actually this value here, right? Directly opposite the angle A, and this is also b. So when we have this one, you have 2 squared plus b, sorry, it's now 5 rather, 5 squared for a and b less. By the way, before we proceed here, of course, if there are instances where you interchange 2 squared and 5 squared, it won't matter. It's still okay since addition is commutative. But make sure that the next operation, subtraction, will always be for this term here, which is a product of 2 times 2, which is the value of A, and the value of B, which is 5. Again, if you have interchanged 5 squared and b squared, you might have also interchanged 5 times 2 here. Again, it won't matter as long as the process or the arrangement is respectively correct. And of course, times the final expression cosine c, which is 70 degrees. Okay, and further, we could compute it in this manner. You will have 4 plus 25 less 2 times 2 is 4 times 5 is 20, but this 20 here is to be paired with cosine 70 degrees. Do not make a mistake like doing this and you saying 4 plus 5 later on then times this one, because 20 is not just a constant here, but it's a numerical coefficient of this expression as a whole. So don't do that, okay? Of course, the next thing rather, you can do this is 29 less 20 cosine 70 degrees. Now here is the tricky part. You need to have the final result of this, or could have the approximated value, but we are requested not to round off our answers because we may have different results later. In order to do that, we are going to use this calculator here, or whatever calculators you have there with you, but I'm going to use this calculator on the internet to solve for the value of this. Now, what we need to do here first is to properly make notations. Okay, so you are going to have it here like this. So you have 29 less 20. Of course, let's do it again. 29 less parentheses, because it should be a product of 2, 20 cosine 70. Notice what will happen here. You have 29 less the parentheses, or a group of the result of 20 times cosine 70. Don't forget that, because if you're not going to make parentheses, it might be a problematic situation later. Where is square root, sir? Let us have it later. As soon as we are done with this, let's click equality. Now, when we click equality, some of you might say, is it okay, sir, if I could approximate it to 22 plus 16 probably? Well, some of it may be acceptable in different situations, but since we have agreed in our class that we will have the final result as our when we since we agreed in our class that the final answer should be the only answer that will be rounded off, let's not round it off at this point of time. So, do we write everything, sir? Again, you can also write this because if I'm correct, this is also non-terminating. It just ends until here, but it's non-terminating. So what is the trick here now? Since you already click equality, what you need to do right now is to click the square root. The value was not anymore there, but simply click ans. This ans here represents the previous answer. So when you click answer, the same value of 22.1519 so on and so forth is now placed on the square root, and this is now the final result. Again, this is made possible because we click equals earlier, meaning the previous computation was then finalized and the result was recorded as the previous answer. So when we click square root and then ans, we have this result here. Once we click equality, the previous answer, which is 22, will now be overwritten with this. So please make sure that you will also try to practice computational skills using your calculator. So definitely this is the value of C now, and this is where we round it off to 4.71. So C is approximately 4.71. This is the result for this value here, 4.71. Once we have this value, we can use it now, right? We can use this to get the approximated value for the angles. Why do I say approximated value? Because in the first place, we are using this approximated value to get the rest. But in order for us to get the other values here, let's say angle B first, we have two options here. I'm going to present here the two options. The first option is where you will use this formula. And since you already have the value for C, B, and A, what is left is cosine B. So we could actually have derived this in this manner. So we can take all of this expression, move it on the other side so that this will become positive. It will help us later with this. So we have here positive now 2AC cosine B is equal to, I'm moving B squared here. So you have A squared plus C squared minus B squared. Again, let me repeat. I'm moving this entire uh, expression on the other side, and I'm also moving this on the other side at once. So I have here, why is it that I did that? So that I am confident that the coefficient here is a positive value, and it is easier for me to divide both sides with a positive number with a trinomial term here. So again, I'm talking about dividing both sides by 2AC here, 2AC. So I will have here the cosine B is equal to A squared plus C squared minus B squared over 2AC. With this, we are left with a cosine B, and we could use later the inverse of that. But first, let us try to get the value of this so that this will be easier. So A squared, as mentioned here, is 2 squared plus C squared, which is 5 squared, less, sorry, C squared is 4.71 squared, sorry, 4.71 squared. And then, again, take note that this is approximately 4.71. In this manner, whatever results we will get later are all approximations starting at this point. Less 5 squared all over 2 times A, which is 2, if I'm correct. A is 2 times C, which is 4.71, approximately 4.71. So we could need to get the value of this first. So you could use this calculator as well if you would like to. So we will have here parentheses 2 squared. We have here plus approximately 4.71 squared less 5 squared. Let me use here parentheses. I can no longer edit it, so let me repeat. And replace parentheses for the numerator. 2 squared plus 4.71 squared less 5 sorry, back less 5 squared, close parenthesis for the numerator, okay, divided by denominator, parenthesis, 2 times 2 times 4.71, okay? So this is the numerator, the complete numerator. Look at this one, 2 squared, 4.71 squared minus 5 squared, parenthesis, to make sure they are as 1, divided by another expression as 1, 2 times 2 times 4.71, equal to this value here. So we have equal. So we have this value here. So let me just write this until what is given, okay? Again, because we are just approximating, but let us not round it off yet. If you're going to treat this as 0.06 without the complete picture, then it might be very different now, okay? So you have here cosine B is supposedly, okay, equal to 0.06 sorry, 850, 850, 3185, but I know that it doesn't end here, so it's like that one here. It's still cosine B. It's not yet angle B. The next thing that we need to do here is to take the inverse of cosine so that we could solve the angle B. So for this, B can be solved as equal to the inverse of cosine with this symbol and this value here, 0.0628503,185, and so on and so forth. But then again, this is not the exact value. That is why some of the references, I'm also going to convince you that in this formula here, we could just automatically change this to B is equal to, erasing this one here, you will have here the cosine inverse of the whole expression. There are some calculators who could input this at once, so it would be better if you're going to do it like that. So we could now erase this bottom portion to have no problems as we deal with further computations later on. So more or less it looks like this. We are going to substitute everything and take the inverse of the cosine. For our calculator earlier, we have this answer here. And since we already clicked the equal sign, the next thing we need to do is just to click the cosine inverse or the arc cosine, the other term for this as well, and then click the ans or answer. Once you did that, the value that you have earlier automatically substitute here, and this calculator, as we all know, does not discriminate the rest of the values. It takes the non-terminating results. In this case, our answer is closer to what is real. So we have here the value of the B, which is our angle, okay? So the measurement of angle B, okay, is 86.40, rounded off into two decimal places. So the measurement of angle B, by the way, measurement of angle B here, as we take the arc cosine or the inverse, you have equal to 86.40. 86.40, and do not forget that it's an angle, so it must have a degree symbol. This is the first step that you could try in solving angle B using the same formula for the law of cosines. But you could also use here another method, which is, I believe, a shorter method, because once you have solved the unknown side here, C, now you have a proper pair of an angle which measures 70 degrees and its opposite side C, which approximately measures 4.71 units. Now that we have this pair, we can go back to the law of sine and use it to solve for angle B, since we also have the measurement for side B here. So the second process is when we do it like this. The law of sine allows us to use the value of the given included side angle, rather, C, And the solved measurement of side C earlier is equal now to the sine of angle B, which is what we would like to solve, and then the already given measurement for B. Take note that we are using the approximated value for C, and hence, again, all answers will be approximation. So let's do it like this, and let's see if we still have the same result using the law of sines, using the solved value for the C side. We have here, or side C rather. So you have sine 70 degrees all over 4.71 approximately must be equal to sine B all over the value of B here, which is 5. So multiply both sides, cross multiply. You will have here, I'm going to use the symmetric property automatically. Sine B is equal to 5. That's 5 times sine 70 degrees all over 4.71. And doing the same concept as this earlier, to make it easier, we are going to use the arc sine here, the sine inverse, to get the measurement of angle B. So instead of cosine, because of cosine, law of cosine earlier, now we have been using, or we are using now the law of sine. So let's have the sine inverse of the value here, 5 sine 70 degrees all over 4.71. So let's do our trick here using this calculator here. Let's try to input all the necessary details. 5 times sine 70 degrees for the numerator to be divided by 4.71. Okay, this is the value. Simply click equals so that it will be deposited as the previous answer. And then let's just simply click here arc sine or sine inverse. And then you have here the answer. And when you click it, your result is 85.99, if I'm correct. So 85.99 rounded off into two decimal places. So the measurement of angle B is approximately 85.99. By the way, earlier it was also approximately. Notice the two answers of the different methods. Earlier, we used the law of cosines to compute the measurement of angle B, and we had 86.40. The other is when we use the law of sine, you will get 85.99. Observably, they are not the same. Even if they are both approximation, they are necessarily not the same. Now, many references would like to round off results for this into the nearest integer. Hence, it will become 86 here and 86 here as well, and that would settle the problem. But there are also some references who are advising not to, since we are approximating. How do we deal this situation? Which is more acceptable in our future processes? Now, there is a good note that I have read on the internet. Let me share it to you here as the question: why is the law of cosines more accurate than the law of sines? This statement here signifies that in the process of solving measurements of an oblique triangle, we may of course use law of sines if the given has a specific pair of a given interior angle and an opposite side. But for situations like SAS, when an included angle does not have any measurement of its opposite side, it would be better if we stick with the law of cosines as it is more accurate. You may want to read this if you would like to. Let me proceed to the problem at hand. So in this kind of situation, my advice to you is this. Yes, we could use the both of the process and probably just decide on rounding off into nearest integer. But let me just have this advice for all of you, and let's take this as part of our preparation. If our problem uses law of cosines, let us use processes of law of cosines to determine the rest. For this law of sines, still even if it is logically correct to have no more problem as to the exact approximation, let us try to skip this and let's just deal with the process for the law of cosines. But that's still a process that is logically and mathematically sound. It's just that the values are can no longer be closer to each other in a simpler sense, so it might not be the same as the other. So we are going to stick with this process for the law of cosines. So we have solved already the third side and the second angle. For the remaining angle, which is angle A, here, we just need to apply the triangle angle sum theorem, which tells us that the sum of the interior angles of a triangle is 180 degrees. So the measurement of angle C is equal to 180 degrees less the measurements given for first angle C, which measures 70 degrees, and the solved value for the measurement of angle B, which is 86.40 degrees. The measurement of angle C can now be computed as 180 degrees less 70 degrees less 86.4 degrees, and hence we will have 23.60 degrees. And by the way, before I forgot, this is still approximation since the value of b earlier is also an approximation. So these are the remaining parts for the first triangle undergoing the law of cosines. So we are going to repeat the process for the next, second, and the third problem here. To continue, let us proceed to the next, and we are to solve first this opposite side denoted as n. So applying the same concern here, but using a different set of variables. So again, this would be m, and this would be p here, which measures 7 and 4. So n is equal to the square root, okay, here. For the square of both, you have 7 squared plus 4 squared less 2 times the product of 7 and 4 cosine angle 130 degrees. Right? This is now computed as 49 plus 16. Let me check. All right. Less 2 times 4, you have here 56 cosine 130 degrees. Am I right? We have here 14. That's correct. So you have here the square root of, you have 5965, if I'm correct. Right? 65 less 56 cosine 130 degrees. So the approximation for that, using the calculator here. So let me erase this. Let's input first the radicand. So you will have here 65 less 56, or let's have parentheses, 56 cosine 130. Okay, that's for the radicand. 65 less 56 times cosine 130. You have here equals. Whatever is the value of that, you simply take the root of the answer. Round it off into two decimal places. We have 10.05. 10.05. Right? This is the value for the length of n. Next is to get the angle. So we could actually pattern here. Again, let's use the law of cosine so that we will be on the same track. So we have here the measurement of an angle is the cosine inverse, or the arc cosine of this expression. But we need to identify or make sure that this should be its expression here. Hence, let us simply copy this one here, probably. Let me have it first here. All right, just for a guide. And then instead of ABC, we know that what we need to get first is depending on the larger side. So let us just use this one here or solve this area here first. So this would become angle P. Okay, so we have here P and then M and then N. So this would become P squared is equal to any of the two, M squared plus N squared less 2 mn cosine P. So cosine P is equal to M squared plus N squared less P squared. Okay, again, using the same process here, we move it there and move the other one here. So more or less like that. And divided by 2mn. So let's substitute the values here. We have m is 4, p is 7. M is 4 squared plus n is 10.05 squared less 7 squared over, you have 2 times m, which is 4, times 10.05 for the value of n. Okay, and then of course we could always change this already to the measurement of angle P, and we apply here cosine inverse, just like that. So how do we do this again in our calculator? Let's take it slowly by slowly. We take first the numerator, parenthesis 4 squared plus 10.05 squared less 7 squared, close, divided by, you have 2, parenthesis 2 times 4 times 10.05, right? 05, that one. Okay, and then you will get equals. So whatever the value of this is saved already as answer, get the cosine inverse of the answer. You will have here 32.24 degrees. 32.24. The measurement of angle P is 32.24 degrees. And using this to get the remaining angle, which is angle M. So angle M here, angle M, the measurement of angle M is equal to 180 for the triangle angle sum theorem, less 130, less 32.24 degrees. And the result, approximately, again, approximately, because this is also an approximation. Yeah, approximation for a while. Okay, so the approximation for this one, the measurement of angle M. Let's try to use this calculator here. So you have 180. Let me transfer it here. 180 less 130 and less 32.24 degrees, 17.76 degrees. And this is now the third unknown value after solving this side and the other angle. So you just need to repeat the process for number 3 here as well. And for the last item here, though it doesn't have any figure, we could always draw this one. So let us try to determine angle Y. So let us say angle Y is probably here. We have angle Y. And since Z is shorter than, let's make it longer. So it's shorter. This is where your Z. So this is where your vertex Z is. Right? If I'm going to connect it like that, this would be your remaining vertex X and small letter X here and small letter Y. This is given to be 88 degrees, and this Z is 3 centimeters, and this is also 4 centimeters here. To solve for the remaining parts, we need to take the use of law of cosines. So you have the y squared, or y, is equal to the square root of the sum of the squares of this. So you have 3 squared plus 4 squared, if you would like to, less 2 times 3 times 4 and times cosine 88 degrees. Just like that. So you will have here the result. That's 9 plus 16. Okay. Less, this is 24 cosine 88 degrees. This is now 25 less 24 cosine 88 degrees. And y is approximately, let's use the same calculator. Here, let's erase this one. So you have 25 minus 24 times cosine 88 and equals to that one. And take the square root of the answer equals, you will have 4.92, 4.92. And since we use centimeters, approximately 4.92 centimeters. This is the measurement of side Y. And then again, let's use the concept of the same law of cosines to get the angle. So you could have the angle here. We could use the same concept here, right? Just for reference, so you will be guided as because we don't have it on our screen already. So to solve for, let's try angle x for this time. I want us to solve angle x first. So if this is angle x, so this would be x squared is equal to y squared plus z squared less 2yz cosine, sorry, that's z, okay, cosine x. That's what we are solving here. Okay, so moving it to the other side as well as this. So you will have cosine x is equal to y squared plus z squared less x squared, okay, all over 2yz. And then you can just simply use here the inverse already, cosine inverse or the arc cosine, and substitute the value 4.92 squared plus z, which is 3 centimeters. We could drop down the unit as of the moment. We'll have it returned later. 2 times y, which is 4.92 times z, which is 3. Okay, going to our calculator, it will have this process. You have the parenthesis 4.92 squared plus 3 squared less 4 squared for the numerator divided by the product of 2 times 4.92 times 3 equals, and then take the cosine inverse of the answer. You have 54.35 degrees. This is the measurement of angle x is equal to 54.35, or sorry, approximately 54.35 degrees. Notice that the unit for the angle is still degrees, no longer using centimeters, okay? Just for guidance. And finally, for the last part, for a while, let's take a box of this. And for the last, the measurement of angle Z is equal to 180, oops, sorry, approximately 180 degrees less the given angle, 88, and the new angle solved a while ago, 35 degrees. So the measurement of angle Z is approximately 180 less 88 and then 54.35 equal to 37.65. Okay, so this is the process for the law of cosine. We just use a different formula which could be debatable, harder than law of sine, but this is how it goes for a situation where it's given as SAS, because we have no other pairs that we could use for the law of sines. Have a review on this one because this is very essential as we learn the concept of oblique triangles. In the next video, we're also going to use the law of cosines, but for a different situation. Use this video as part of your review. Thank you very much. Thank you for your views. Goodbye and God bless.